All right, the final slide that we are given for these 3.1 flips is certainly a loaded question. This function right here, we have that in standard form, and what we want to do first is put it in vertex form. All right, so vertex form we know is this structure, y equals a times x minus h squared plus k. So we want to get this equation, or this function, rewritten in that format. Okay. So in order to do that, we have to complete the square. So this is the structure that we will go through each time when we complete the square. So we'll have g of x equals, and I'm going to take the quadratic term x squared and that linear term 8x and put them in parentheses. All right. And I'm going to kick that constant term out. All right. What we will have to do is utilize what we talked about earlier with completing the square back in chapter 1, where we do b over 2 squared. So in this case, our value of b is 8. So we're going to do 8 divided by 2 and square that, and that will become 16. So what we will do to complete the square is we'll add 16 here. And now the next part is going to be a little bit different. In order to keep this equation balanced, we're going to leave everything over in this structure on the right side, so it'll just be g of x equals. So if we add 16 inside the parentheses, we're going to subtract 16 outside of the parentheses, and that keeps the equation balanced. Now, from there, we'll have g of x equals, it turns out that the x squared plus 8x plus 16 is a perfect square trinomial. So that will factor into a single factor squared. And we can take the square root of x squared, which will give us x. We take the sine of the 8x, which is plus, so that'll be the sign here. And then take the square root of 16, that's 4. So that portion is x plus 4, that quantity squared. And then 11 minus 16 is negative 5. All right, it's a very simple case, but that is now in vertex form. Okay? So we can graph that real quick. We know that the vertex is at negative 4, negative 5 because of the plus 4 inside and the minus 5 outside. So negative 4, negative 5 would put us here for our vertex. All right, so we have that point. Utilizing what we know about quadratics, if my value of a is 1, which it is in this case, I can move up 1, and then 1 squared is 1 times 1 is 1, so we move up 1 on each side. And then if I'm at the vertex and I move to the right 2 units, 2 squared is 4. So I move to the right 2. 2 squared is 4, and then times my value of a, which is 1, is 4 as well. So we would go 1, 2, 3, 4 units up, and that will be mirrored on the other side as well. Okay, so 2 to the left from the vertex, and then 4 up, 1, 2, 3, 4. All right, that gives me a nice sketch of our graph. Okay, so that's taken care of. We already talked about what the vertex was. All right, the vertex is negative 4, negative 5. So that's taken care of. The axis of symmetry, we specified in the previous flip that the axis of symmetry is always equal to h. It's always x equals h. So axis of symmetry is going to be x equals negative 4. All right, it's just this value right here, the x coordinate of the vertex every time. Okay, so that's taken care of. Make sure that you write it out as x equals. All right, axis of symmetry is the line that divides that parabola in half. So if we were to view that, the x equals negative 4 right here on the graph, it would be this line. All right, you can see that is the line that divides it in half. All right, in terms of how it opens, we'll skip the intercepts for a second. The value of a is 1, it's positive, so obviously this graph opens up. And while we're at it, we might as well specify that that vertex, negative 4, negative 5, is a minimum. Okay? And then as far as the intercepts are concerned, probably the easiest one to find is the y-intercept. All right, and what I would do is view this initial form right here to help me find the y-intercept. We know to find y-intercepts, we can plug in 0 for x. So we'd have y equals 0 squared plus 8x, or 8 times 0 plus 11. So that is going to become y equals 11. So our y-intercept will be 0, comma, 11. All right. Now, with the x-intercept, you could either utilize this standard form right here, okay, or you can use the vertex form. All right. We know that with x-intercepts, we're going to plug in 0 for y. So it's your call as to which one you would use. Now, if it's factorable, this would probably be the best version to use because we can factor pretty easily. However, there are no two numbers that multiply to 11 and add to 8. So we cannot factor that particular one, which would mean we would have to use the quadratic formula. If you're comfortable using the quadratic formula, go for it. All right. I think in this case it would actually be easier to use this format and solve by extracting square roots. All right. So if we were to do that to find the x-intercept, we have 0 equals the quantity x plus 4 squared minus 5. All right, we would add 5 to both sides. We would take the square root, so that would give me x plus 4. Square root. X plus 4 equals plus or minus root 5. And then we would get x equals negative 4 plus or minus root 5. So the x-intercepts in this case, we have 2 of them. All right, they would exist somewhere here and here. All right, and those coordinates would be negative 4 plus or minus root 5, comma 0. Keep in mind, we also call those roots solutions or zeros. And that is all.